Okay, so please comment on the video. It helps me with the algorithm. It looks like I had to do another video. I pulled this out of that last video. It was distracting from the BMA. So you guys really had interest in it. Let's go back at it again. I want you to take note. I'll do it the same way I did in the video. I want you to take note of the back wall here. And take note of the back wall. So it's a pool, and now I noticed this coping at the lower level. Coping, I call it. It's the red tile area slopes away from the pool, back this direction. So I guess you wouldn't want water to run into your pool. Here's a drain. Here's a drain. There's a drain over here. Now, over the drain to the back wall here, I believe this is where we get our rusting rebar. Our rebar that's jacking off the concrete there in the back. All right, it looks like that's about a terrible thing. That deflection, I think, does not exist in the system. Now, as I scroll over, we're at the hot tub area, and that's probably the filter system for the hot tub. I already know about people saying this is where the flower pots were. Yeah, sure. There were flower pots there. Without me saying, for new people, old people already know where this goes. They've already seen the video before. What do you observe in this image? What do you observe in this image? Right there. So I'll stop it right there. Now, let's go ahead and go to this one. There's the hot tub. Right about there is where we get our break. Back to the image. So it's a little bit over the column, right about there, hot tub. Column, a little bit over the column, hot tub. A little bit past the column, right there. That's, that's data. Let's get rid of this. Now, this is going to be really interesting because I'm going to change a little bit of the data here. This appears to be a walkway here, and they bulkheaded the walkway. Bulkheaded. So this does not appear to be the existing wall over here. It seems like there's some distance there. It's not as close as you think. It's compression. The lens pulling in, making things look closer on top of each other. So you'd look at this initially if I told you, hey, look, this is right next to that wall right here. You might believe me, but I see the different layers. You got what appears to be a white fence, a white material, then another fence material here. The fence looks like it's proud, standing strong and straight. So it looks like they bulkheaded down here. Steel bulkhead all the way down. I don't know how deep before they started pouring their floors. This is their steel that they're going to set up up here, I believe. There's their columns, but this looks like the steel they have sitting out on the deck. Take note of the ponding in the deck. This will be where this is outside the structure, but it's ponding. It's just the craftsmanship. The water run. Look at my message. The water runs that direction, and that's a dip in their deck when they poured it. And so flatness was not critical, obviously. Back to the deck here. You see, this is. I forget who I have to shout out for this. Sending me this, Kadashi or Das, one of you. This is where our failure happens right here. Now, right about here, is a column out. Oh, I'm sorry, internal. So let's look at that. I want you to understand the column situation here. Here's a column here. See this column here is a BMA that's supposed to go across there. This is per architectural plans. And this is supposed to be 11 foot 10 on this side of the parking garage. On this side in the pool deck, we're supposed to be 10 foot 10. That's the difference of a 1 foot elevation if you're going from this side to this side, going up. Elevation drop if you're coming from this side into the pool area. This is the parking area right here. They had another BMA right here, another beam that was. What else could it be used for? I don't see anything else loading there. This is very interesting in itself. Was this part of making this deck rigid out here? because it's sitting by itself. There's nothing loading above it. As far as I know, there was nothing loading above it. The flower pots were always supposed to be on the outside here and in this direction. But for some reason, they put in these BMAs here. Let's see if we can peek at a BMA, if I get this right. Okay, wait a minute. So that would be over here. All right, so back to that. I was able to find this via, I don't know, another one of your viewers sent me something, and I took the screenshot out of the video. This is where that deck appears to do its dip, right about here. Hot tub's over here. Here's a floor drain. I believe there's another floor drain over here somewhere. But this looks pretty flat here at this time. This is around a 2015 video, I believe. The flower pots are right. The flower pot stations are here. You're looking at them here. This is not something lean there. This is a wall, a little knee wall, and there's planters inside there. Trash can. There's an opening here apparently. The wall sets back a little bit, but that's that wall. The wall stops right where it appears to stop right where our break is also. So our wall stops right where our break is. Butterflying down the middle here, but right there. Now there is again the flat wall. So we go to out of this one. There's that wall system. Notice this column on this side of the wall of the planter. This column alone, just this one, on this side of the wall, ripped out, and there's some rebar here. Let's address that one column. That one column would be, so here's an offset. If I draw a straight line, see it? It's offset by this much. And that much is in the other part of drawings we talked about in the first video. Show the offsets. But it's offset, so that column is right there. And then the wall is back here. So the wall is sitting on this side of the wall of that column, not directly on top. And when it shears through, it pushes that wall on an angle just like that, rotates the wall, pushing it off, because the wall was built last on top of the system. It pushes it off. Right here, this is the line that we would be following, right? Let's keep track of that. Here's the engineer's line. See the BMA against the wall here? That would be the line we would be following. It would have a transfer beam here, a beam that would support that underneath. An idea of what they look like in real life would look like this. And then I'll come back to that picture. Oh, well, let's hit this real quickly. This blew over. There's a sign right here. It was, the wall blew over. There's the hot tub. There's some ponding right here. There's the same thing I keep seeing. It looks like a high drain. It looks like a high drain, if you ask me, because it keeps showing up in multiple images as something kind of odd one-off kind of weird thing. But it seems to find its way into each one of my images almost. There's the offsets that I'm talking about. There's the literal offset numbers. So that column is the first column. Let's see, parking garage is this column with the planters going out here. The second column that you see is here. It's and let's see, let's get this right. Yep, second column is there. There's an offset there. So the planter box this one rotates in. The planter box is still straight. This one's on the outside of the planter box. Outside of the planter box. We'll get to that image. See, it's on the outside. Here's the planter box. This column's on the outside. This one's on the inside. And now you can understand why the location of those columns. Because they're not in line. See, one's here and one's here. So now you can see why when the planter boxes fell down this side, the shearing took place on this side with the cars going down. On this side, the shearing still took place, but the planter box was image. But the planter box was such that it was just about on center line of the planter box where it fractured it and turned it to fracture the box and turned part of it out. And I believe this is the other part of it down below. See this gate, this fence here? It's down this angle here and here, so you can see where it fractured. But it's still, and it's on this side of the planter. There's the planter box. So part of the planter box got fractured and pushed off to the right here. Part of the planter box stayed in place there with this column there. All right, and it looks like, and there's the rebar connecting the maybe the deck, or it could be part of this column. I think it's the deck, because I think on these heads we only find, so far, we've only found four pieces of steel coming out max. 2 and 2 this direction, 2 that direction. I don't see any other direction in this way bent over. Well, because I just don't see it from this video. So we have this dropping straight down this deck here. Like I said, looks like an elevator ride it took down. You can see the top of the steel is bent a bit, so there's a little torque action on the back side when this part collapsed, or secondarily collapsed and slammed the deck and pulled the rebar and pull down on the back of the deck a bit there. Let's go back to the image surfing. We can get rid of that. So we have these guys that I was talking about, them playing workshop, right? Playing workshop, teaching each other how to do the jackhammer. Do you remember that video there? Well, here's that area there also. It just happens to be, this just happens to be there. We're going to look into this in a second. Cool, refreshing drink. It happens to be there. If we look in here and look at the cross section, we see it. Part of the sidewalk was under there. The wall is in good shape, so it pulled it out. Whatever it did, it pulled out, and it separated. And whatever it was also integral with that side, because these are fractured and pulled out. It's not like it's two pores. This one, on the other hand, looks like a nice fracture right here. It looks like a nice clean fracture, but these look like they fought a little bit. There's some rebar turned out this direction. I see rebar right here, up here with the shadows. I see rebar here. So I have a conflict with that engineer that contacted me saying that she or he saw, whatever, no rebar sticking out of here. I asked them to send me photographs to prove it. I have to be wary, guys. It's not the first time that I've been baited by the narrative. I believe that that you guys clearly can find, on that they hire public relations people, and the public relations people's job, you see it in the reports. If you do a FOIA request, you'll see that which firms they hire and how they try to control the narrative. I've personally been contacted by attorneys that have told me to cease and desist from a couple of my bridge videos. I did not cease and desist. I said, I'll see you in federal court. So no, this is a right of mine. They use attorneys to threaten you. And of course, I said, I'm just going to hire the best lawyer I can, and we're going to then test this. We're going to test the right of fair use rights. We're going to test that. If they want to be the first to test it in federal court, I'm sure that I will prevail. I'm willing to put my dollars behind it, and I'd ask for a GoFundMe too if it ever came to that. But mostly, or should I say, all the time, they cease and desist. They go away once I say let's take it on. There was one interesting one. I actually asked for let's sign a do not disclose, and let's have a conversation, a little deeper conversation. They didn't want to do it. They didn't want to disclose their client to me. And I'd love to tell you who I think the client was, because it was the only one related to the damn bridge. But they never signed that do not disclose. And if they did, at that point, I wouldn't be able to disclose it. I could theorize now. I could tell you the bridge. I can do a bunch of stuff now because I don't have any agreement with them. But that video doesn't need me to take place at this point. Besides this, stating that, yes, maybe the person was an engineer that worked there, Or maybe they were part of the public relations team that was called to give me misinformation, to have me, jerking off on the wrong location. So I see steel here. Now that engineer made it clear that she was there, and there was no rebar at this location, at this back wall. I see scratch marks down these walls that are indicating of like rebar, unless it happens to be the perfect spacing of the concrete sliding down and doing that. I see shadows that indicate rebar right here, reinforcement here. So I have to be careful of some of the people that write that they might be a Trojan horse, and so no Trojan horses. All of these like this, see all these spots, they indicate rebar blowout. As you grab rebar, you do pull-out test on something maybe not too deep. This would be the rebar blowing out, each one of these divots. That's what they indicate to me. This, on the other hand, indicates to me that the rebar pulled out all together, one section. So there might have been 3 pieces of rebar here, or 4, and all the way down to here. And they just pulled in one grouping. This grouping here. This grouping, when it pulled out, it burst the rebar. There are cones, if you can imagine, that are the forces that are in play here when you're doing pull out. Yeah, this one I'm not sure if I meant that way, but you can go that way if you want to. So we have vehicles under here partly supporting this structure, perhaps crushed. The shifting back, I think, would shift out, and then it buckled this section back because I can't straighten this section out right here at this point. So that shows you that it pulled away, and then it buckled from here to, let's say, the scratch marks are down, up here to there, and then it buckled, and then it came down and found what I call equilibrium again. Maybe another car's under there, but that's a secondary buckle, a folding right there. All right. So I just want to talk to you about that. Now let's go back to, and that's by, and they column marked them, that's L. So if you guys want to deep dive into that, you sure can. So, but what's more important to me is the planters. This is where the BMA is. I don't want to distract you too much on that picture of that deck that you obviously have already seen. I don't want to distract you too much. Where is it? On this. Because this might be a floor drain here, that one that keeps showing up. Which means they pitched that water over there, and if they did, the survey, you got to give me a break, buddy, whoever you are. Got to give me a break. All right, so that pitch, the survey of the engineer said the deck was ponding water, etc. I go back to the tile guy. Wouldn't the tile guy be responsible for any engineer that spec the tiles? Would they not be responsible for waterproofing the deck before putting down all these tiles? Why is the engineer, going all the way back and blaming the original designer? If the next guy in place put these tiles down and didn't waterproof below his surface. And clearly from all the comments I saw, and some of you guys might be figuring out what they were talking about now, you'll know, is that this looks like a pitch, right? And it's going right back towards the cabana right here. And the cabana goes back to the wall, goes back to our failure zone. So here's your offset where you see those columns. So that explains that. Let's see what I got above. So that's what it looks like there. And I'll do the video thumbnail there. And there's a little bit of sort of all the offsets and torquing action. I had some clown that tried to come here and tell me that something, whatever. You clowns get the link, you get the PayPal link, and then you just get blocked right after you respond. Because I want to see if you got balls enough to respond. Some of you do and say, "Why should I give you money?" If you make a demand of me, such as stop the joking, or you should be more serious, and I send you a PayPal link, and I'm asking you why I take 2-3 hours to make these videos, because sometimes I edit, sometimes I delete and start over. That I ask you for the $150 an hour that you put in my PayPal ahead of time, and you tell me which video you want me to do also. You don't come here and tell me what to do. Fuck off. So anyway, here we are here. This is after Hurricane 2005, perhaps. I forget which one it is. Here's your ponding right here. This is where the deck ponds. So this is where you would look for water. You would look for water not by the flower pots, but in front of it. We see a gap there. So in front, round this way a little bit, here, and here, right here, where there's the hot tub, and this is now a glass door, that or appears like glass framing. The frame's going to move so fast in this one, they're going to be gone. Oh, it's not a frame. It's not a video. Let's see if I got one up here for you. So I try to go through the video. There we go. So, cabana. Oops. Cabana. There's that wall. This is 2015, I believe. And 2015, I tell you, my bias, confirmation bias, I know I'm trying to think of lens and photography and all. I froze this when it was right about the middle of the frame. If it rotated, the distortion would have been more on the outside, as I talked to you guys about. Right here is going to be the least amount of distortion, right about there. And that's right about where we are. I'm biased. I really don't see them putting these chairs on that slope there. It's coming down. That slope seems like it's, I got to be careful here. But that slope seems like it's produced itself. How's that? I'll use that word, produced itself. Here's the cabana over here, right at the edge of it, right there at the edge. So we got to go from the cabana to the left a bit. All right, so let's do that. Hold tight. So with the cabana to the left, oh, that puts us here. Isn't that something? Here's the column, and doesn't that look like now we're in the flower pot in this configuration, across this configuration? Does it not look like it's not level to you? Does that look like a beginning of a punch? I'm just being totally biased on this, guys, because I see what I want to see. So I see what I want to see, and I would love for you guys to see it too, but remember, we got to be careful. Do not support me on just to support me. You got to see it yourself. You've got to see it yourself. So I went across the top of there. Let's thin that out. I went across the top of this one. And I'm not, it's not happening here. Now let's go with the vanishing point a little bit. So the vanishing point, I'm just trying to figure it out. Okay, the vanishing point would be along with this edge here, right? So let's just grab it and move it down. And it's still not matching that pot over there. Let's grab it and move it up. They seem parallel. And the vanishing point, it seems parallel with the wall above. So let's use the wall above as our vanishing point because it's more in line. Probably splitting the difference a bit. It's pretty much there. Now let's drag it down. So that looks like it's about in line. I'd even say it's almost in line with the one to the left based on vanishing points. But now that seems like it's a little bit low. Let's get the old magnifier out. Let's enlarge it. Let's bring it over. Now that tip there, and that's, bias on my part, that tip looks like it's higher than that tip there. And they look even Steven across, biasly so. So I have this guy, looks like it's no longer there. This is our dip section, right? Isn't that our dip section? Let's scrub through here while we got this magnifier. Delete. So that one's a weird one. Let's do this one more time. Let's do it twice. We liked it so much. We liked it so much. We had time to do it twice. So let's grab the bottom. Now I'm way off. the bottom of that pot and the bottom of that one nowhere in proximity. Let's see. That's a little bit off the bottom. That's way off the bottom. That's closer to the bottom. And I'm still way off the bottom over there using the same vanishing points. Let's do a little verification of the vanishing points. We can change its size. And our vanishing points are about equal. Yeah, I got a little tab over there, right? So our vanishing points, you know what, let's do this. Magnify the vanishing points. So you'll see that I'm all over the top a little bit there. I don't think I can move this down inside once I do a vanishing point. Yeah, I don't think it's going to allow me to move. Yeah. Alright, so let's move that there. And let's put this down here. And let's vanishing point it. Yeah, it seems about the same gap. See that small gap? Let's try it again. Let's see if I can nail the bottom a little better this time. Now I would say that's a little bit closer. Oh, it's close. It's very close. Very close. I'm not going to kill myself anymore with that one. So I used a vanishing point from the back wall for the photography and slid it down. Then we came across the pots here, and we see that these pots are the elevations are definitely it's near our dipping points beyond the umbrella. It's not the first one there. We go to the photography. We know where here's 0 column, 0, 1, and 0, 2. I'm sorry, 0 column and 1 column and number 2. So 0, 1, 2. Where are you? Don't save. Great. So right there is that pot, that dipping, I believe, right there. I can't get any closer than that. There's the pool. So now we've explained why this column is inside, why that one's outside. We see the dip in the pool. We talk about rebar reinforcement here. We see that they're over there by there's L. It's marked on the wall. Let's see if they zoom out a little bit better. Let's go back. Let's see if we can do this. Okay, we're going back again and again and again. Okay, so that would be the planters there. And right beyond the planters, right about here is or maybe our failure. We're going to get real close to that by chance. So here's our planter box. Here's that one that stands up. So this is, I don't know how it's marked, but there's the one that's punching through, and these are where the cars were. So we come back to here. Nope. That's leaning over. All day long, that's leaning over. So where is it? Oh, they tore it off. It's gone. Hell, the other one's gone too. They're gone. They're already gone. But here's the planter box. Here's that bent railing. The railing's taken off even from here. They even removed the railing in this outer wall. This is the canopy right here. That metal canopy. Maybe it was open. Nah, that's not thick enough. This is maybe construction crew stuff they trashed. I don't know. But interesting, our butterfly puncture. Here's our ripping of a wall. That looks like it was reinforcement. This is a new temporary wall they put up with sandbags, bracing, torn system. Well, that's nice. Where's our other column here? AOL. AWOL. Alright, so I think I beat this up. There's M, there's L. L is where we have the, oh, the guy just walked through. That's funny. He just pulled the tape through. There's L, where we just walked through. It was probably for a fire hose or something. They were pumping water or not. He's sitting on the wall, part of the planter box and location. Well, I got to tell you guys, they lack oversight. They're all engulfed in this 3, 6, 7, 8. They're all engulfed in their thing. They lack oversight. A person overlooked that would keep an eye on them. This person's not oversight. They're not. It looks like they're resting. They say things like, "Yo, you're about to step back in the hole," da da da, you know, something like that, or you know, someone is observing all of their actions in one shot, and that we know it's not that person because he didn't jump and say, you know, stop stepping back, stop stepping backwards, and he stepped back again, and you're talking to a person that situation awareness. I'm good at it, but when you start getting on something like this, your brain will program you're on a deck. There is no hole behind you. It's too late. I know that. I've walked off the one bunk. It's bunk, right, when they call it scaffolding. I've walked off one bunk of scaffolding twice in my lifetime. You think you're on a damn ground, and there's no protection there. That was years ago, you know, when I wasn't that bright. Walked off because of the plank. Not because I didn't walk off too far. The plank, I assume, was secured. Stepped on the edge of the plank. The edge of the plank was not at the edge of the scaffolding. It was beyond the scaffolding, and I went down to 6 feet. Never, you know, I was able to just land on my feet. But I was like, son of a bitch, really? And then it happened a second time. From then on, never happened again. I don't go, you know, your scaffolding, if it's got any overhang, I look at you got to use hook scaffolding boards for me, or I have to see it strapped at the ends, or I don't go any scaffolding. I do an easy pass. I don't go any scaffolding. Here's that deflection again coming down. So I think we beat this up enough that we got enough data here. You guys can rewind this video. You can look at it over and over again to grab it. This again, the BMA is what I want you to stay focused on. Right about here is our L column though, right? Or this one doesn't. This one, oh yeah. So there's L. So here's L coming down to here, and there's our. So they're right next to L. They're punching into this guy right here. Let's do that. They're punching into L. So here's L, and they're right around L playing games, right? So, and if you take offense to it, don't worry. I curse, you're out of the room. Go hit the road, Jack. They're punching around there, and I don't see an indication of the BMA in there. Oh, that's what I wanted to show you, BMAs. What they look like. So, there we go. So in a lobby, this is what a BMA looks like. This would be the composite. I want to say use the word composite beam and column mixed integral together. So it looks like that. And it looks like that coming across. And it looks like that. And it looks like that. So that's what you would look at in the garage. And in this case, this is I think this is might be the lobby of the same building, or to the right, older image of it. So the building that stayed, the part that stayed, this will be the that's the first floor. And this is also the garage floor right out here. This would be the second floor. And that's where the BMAs all interlock like that. You can imagine how those BMAs, look at that. Imagine how they would interlock right there. So imagine how they would interlock down here from this side to this side, especially with 11'10" and a 10'10" step down. So there's a step down. I played dumb caddy. I even did a video on it about how I had to thank you guys for pointing me out that I was looking at this wrong, that the rebar was not going inside there, that it was, oh my gosh. I had all of you telling me where to look for. I'm like, all right, well, tell me more. Run with it. I was dying for you guys to run with it, to see that this should have been a BMA. This is a BMA also. Supporting this elevation change would be a BMA. The BMA goes all the way across, would have supported the elevation change, which would have made the parking garage separate from here and made this composite beam looking something like, let's do this, looking something like this. So I can write on it. Nope, yep, I'll just do this. So come on, okay, that's good enough. So this is our pool deck down here. This is the columns, the parking garage down here. And that way we'll make that one bigger. So here's our parking garage. We'll just extend it all the way down. Right? We'll make this, great. We'll take a little liberty here and call this a pool. I want to make sure that it looks really funky. And swimmer, help me. I can't swim. That's a swimmer. So pool way over there. There's the pool deck. All right, this is tied into here with the reinforcement, right? Let's see. So like this. So it's tied in here with some reinforcement. Hopefully, right here, this all loads down like that. All right, down the column. This deck loads into here, probably in the column format, but offset. See how they did this? So this one, because this column's offset over here, they gave us some reinforcement, a BMA, to help support it in that span because of this cross section of the deck, the car parking. But now they removed this BMA, they erased it, and then we get the cars just parking around it. I'm going to talk to you about Tributary things. So Tributary, I'm going to do a video on that, and I'm going to show you how that ties in. So I'll tie it in for you. Tributary, to give you a cheat, I want you to think of your floor joist in your house. If you live in a wooden house and you know you have your floor joist space, let's say 16-inch on center. I want you to remove one of those joists between three joists. I want you to remove the center joist. What happens when you remove that center joist? Your floor sags, doesn't it? That sagging area, if you will, is the tributary area I'm referring to. Now, that tributary area, we don't want it to sag. So what would you do? Well, you would increase your floor thickness, or you'd add some reinforcement inside your floor thickness so it doesn't deflect. And now you can get the greater spans. So that's the tributary area, basically. That's one of the best explanations I can give you of tributary area. And they're between all of these spots. Here to here, here to here, here to here, here to here, here to there. And now, amazingly so, the tributary area is also from here all the way down to the pool deck. The pool deck is where we get that fracture, that split, as you remember. And there's no conjoint there. The fireman is there, and you see it. And show you in other videos where there's no rebar holding together. That's part of my butterfly failure right down the middle here, because this is all tributary. This is all tributary, right from here to here. No matter what anybody tells you, and there's a loading of the concrete of the steel of the planters here. And then we have the loading of the cars over here. So we get the extra loading here across our zones. All right, so let's add. You guys need to add. Okay, so I need to go command copy. Really thanks to the person teaching me that. Oops, copy the wrong thing. Oh, apparently I'm copying some damn. Oops. So let's add our 6 cars, right? Let's just throw 6 cars in here. And we got our 6 cars loaded in here. This BMA doesn't exist as far as I know. So this car is not being transferred down that BMA, down these columns. Remember what a BMA looks like in that apartment building. So those loads there, and here is a wall here. There's that wall where we see it shear off. These loads here are all 6 grouping together, if you will. And it's an unsupported span besides this column from here, the center line. Oh, I guess I can move this over a little bit. The center, right about there. So there's a load on this side. There's a load on this side. All these loads are trying to they're trying to share across from each other, all the way to, in this case, here's a column way back here. Here's one. Wait a minute. There's one here, and there's one here. Huh. And there's one over here. So the next one is where? Oh, it's over here. I'm sorry, I'm blocking it. You know the way I'm being facetious in the way I'm talking. It's right there. All right. And there's one over here. They're scatterbrained everywhere, right? So the tributary area is going to change. In other words, your floor joist, your span, there's your floor joist. Now imagine your plywood over top of all of this. It's just this area here only first. Your plywood is on top of this. And then you load it with vehicles. So this one seems like it'll do pretty good because it's pretty close, this column and this column. So this car back here actually doesn't exist because they didn't put a car around the column. So it actually doesn't exist like that. That would be more like, isn't there 3 cars over there? Shit. Three cars. 1, 2, and 3. So 2 are on that side of the column and 1 over here. Okay, there we go. So 2 on that side, 1 over here. That one's right pressed against the wall. So I put the 2 over here. And I move this one over here. Right, and the flower pots go down here, and they're pretty close. So flower pots are, they're out here. Not quite scaling my cars properly, am I? Why is that car taking so much room? Makes me wonder the location of this column now. Oh, it just doesn't have the other car in there. There's two cars here, and there's 2 there. So there's 4 cars. This one just doesn't have the other car pressed in it. Now it does have another. It does have another car though. So we got 4 cars here, and I get to put another car in. So we have 4 cars there, and 4 over here. Yeah, I'll just put 3 there for now, just to make it fast. So shit. So let's put the 4 cars there. I guess that would be 2 and 2. Oh, the longer one. How about that one? That's the truck. Everybody wants to talk about that truck, right? So let's make that one. And then we got this little car here. Then we got one car that kind of fell over a bit, leaned over this side, rocked over. Well, look what it's rocking on top of. It's a damn shear plane. Shear plane being a column. Remember, we got the car leaning over? That's that crack. This is the fracture we see here. So we have our dividing fracture. Let's change colors to heavy green. So we got a dividing fracture right down here, which sits right on top of the column, right? So let me do that about that size. So we're right on top of the column. There's our loading, and then we get this joist missing, if you will, down the middle. But how do you make up with it? Like I told you, you can reinforce it with steel coming across here. But ultimately, so what, you reinforce it, and this doesn't deflect at all. Say you get it so tight with steel that it doesn't deflect at all. It still has to carry its load down these columns, carry it over the columns. This load, it couldn't do it. So it breaks free, punk shears away from it, right? So it punk shears away from it, yeah, great. Trying to give you a cutaway a little bit of the column on an angle line here. hell with it. That's the column there. Now you see that little ledge right there where it breaks free, or fractures free. Actually, that would be more like this. Oops. Kind of hard to make this mouse work to cooperate with me. So it'll be more like, oh, that was interesting. More like that, and it fractures right here at that column we see, right there, this column, and it drops down. That's puncturing, and that's because I wanted to show you. I'll show you in real life. So we have to get the butterfly there because it didn't just slide down altogether perfectly. It had a butterfly effect going on, and it hit the cars. If it just dropped down like an elevator, it would hit the cars, and we'd probably see a fracture in up area. But we have to get this separate from here. It's still tied to the structure over here. So I have this tearing off first. This is our first fracture right here. This is our fracture line. Our fracture line is here. Smallest section here. Cars come in. They all are loading this area. These 8 cars every day are cycling this area here that causes the fracture. It develops the fracture. Okay, they come in, they stop their car, and they back up. They come in, they stop their car, and they back up. This one comes in, stops their car, and back up. Every time they do that, they charge this area here, this right around this section here, which would have been where a BMA is. They charge it, meaning they put a load on it with their braking each time. Vroom, boom, vroom, boom, vroom, boom. This one might charge this area here. Vroom, boom, backing up. This one might charge this area here. Vroom, and then back up. Right to the column, and then back up. This one wants to back in. Comes right to this column, maybe, if the car's not present, and then backs up. Enough of that charging, enough loading and pounding right here starts fracturing around the columns. It all starts working on there. Plus the dead load is now working on it. No BMAs. Over here too. These cars come in, they want to get there, they come this way, maybe they charge it only here, but it stresses the column here. We do have some interconnection here, but there's a flower pot back here. It's got to go around. It's a redirect, I call it. So, nevertheless, we get these 4 cars going down like an elevator. When they go down, because they're on the same level, they're not. This is 1110. This is 1010. This doesn't exist, right? Let's get rid of these cars now. These cars, removing the cars for a moment. This is the floor elevations that were supposed to be 11 foot 10. This is 1110 right here, and this 1010. We're supposed to be right. This is supposed to be 1110 and 1010. This beam with stirrups and everything else. This beam right here. We're supposed to have all types of stirrups, connections, look like this. Actually, I want it to look kind of roundish. And then like this. Well, that would be nice if they did that, but I don't think they designed it like that. And then like this. And, oops, too late. So that when you do the steel caging, if you will, and you put concrete around it, this can't. What's up? What's up, Georgie? What's going on? What's going on, Georgie? Georgie's right here at my desk, just decided to talk. So this acts as a beam also, because the spans on this now, they're funky though. This beam here is pretty big, even if it's a beam. I don't know what she was going to be, how she was going to be built, but she was going to have something to her, because that's a heck of a span to go from here to the top of this beam, and then from this beam over to this wall. It's a heck of a span, but they were going to intercept it and load it, have it, because it was too great of a span. The beam would be so high they would lose their clearance for vehicles to get underneath. They put another transfer beam to take quite a load here, so basically it would go there, and it was cheaper than building a column there. So their column layout was, let's put a column here because our span is now here to here. You know, I I really don't get why this column, this tributary area is so confusing to me. The tributary areas are just mathematically and rebar reinforcement. It's I'll have to show you what I mean in some real rebar. I'll lay it out. But these offsets, all I see is beams being created. But it would have been addressed if the rebar went this way and this was the load bearing. This would be the load bearing section of it. Here, this BMA right here would be the load bearing section of it. This is just, oh, there's a span. There's an intercepting column. There's an intercepting column. So the span is here to here. I was looking for this other one. But this span shifts. But it's still straight because they picked it up on top of this BMA here. So it'd still be straight. And so this basically would be another column. But it's not a column, it's a header, if you will. So the span is from here to here. And that's a great span. So this would be the one they'd really probably enlarge. And this one they could make shorter if they were going to make BMAs. They don't have to make them the same size. This could be a smaller BMA than this BMA between here, continuously across. But this would be a large one. That would be a smaller one. And then depending on that deck loading, this 7-foot deck, this would be scaled to size for that. And then over to the wall here, there's a car that goes back there. The car's back up. The steel redirect, the loads, this became a wall. It would be a redirect in this capacity. This is where I would think this BMA would continue all the way out to here. Is where I would think. Actually, all the way down if the steel is going to go that way, because it's just weird. This, well, actually, can't confirm this depth from here to here yet. I don't want to get caught up in the weeds, as they say, right? Let's leave me out of that one for a second. So this is what it would look like, and then we get this. In reality, we get this. There's the building. This is what the part of the report, they said this building construction interfered with this building here. They said that it's right about this column here because it just happens to be there. But they have these columns, they're at the basement, and they're intercepted by these columns. So why wouldn't these columns fail first? They're a little bit larger, but why didn't they fail first? We have the columns over here, but they're not connected by a BMA. If they were, we would be able to argue that, oh yeah, the vibration shoved on this BMA and shoved on this column here, which made it weak, and might be our starting point. But that BMA, that load path, doesn't exist. It exists in concrete surfaces all the way over, but we've got a history of 2018, I think it's before this build started, of this deck having issues. This is nasty. All this ponding water. Really, this is not going to happen today. Really. I'm not reading messages. I'm just calming down. So now we have. So now you see the columns. Why the columns are placed there? Now we have these guys. We see that area there. We see rebar in this back wall. We see the deflection in that deck. We see that this looks like a rag or something. I wish he would kick it. It drives me crazy. This is that thing that keeps reappearing. Right there. They're going at now they're the fire department. They're not the forensics people. They're the fire department, just practicing jackhammer. We did a video on that already. That's L. Let's talk about that one more time before we go. So that's L right there. And they're jackhammering this one right here across L, exposing it. It didn't fully punch through. Over here we have our fully punched through over here. This one This one did not fully punch through. They're trying to expose it now. This is more videos. I'm going to end this. I just want you to show that one didn't fully punch through. It landed there. My butterfly's back there. You can start getting the wave effect. I'm going to put this together as a wave effect there. Hell, that looks like rebar right there from the end of this wall. It might have been over there, anchored into the wall system. Oh, incidentally, all the rebar that I saw, it looks slightly scaled, if anything, slightly rusted, and it's looking great. It doesn't look like it's swelling and all that other stuff, you know. Oh, fuck off. Sorry, guys. Ending vid. Oh, there's 42. There's 42. Ending it with that thumbnail. Or was it the video? This one. So what do you see there? What do you see there? And does it amount to much? This appears to be a drain. I don't know if it is or not. Does it all go to that direction? 42 is right about here. I mean, it looks that way to me. You guys mentioned it also, that it looks like, you know, we got some tile pitching and all that. Yet we had the report stating that it didn't happen, that the deck is flat and it's holding water and it's doing all types of crazy things. If you look over here at the ledge, you can see that this appears to be the deck and that appears to be the topping. Huge amount of dead load. So this appears to be where the deck originally was, and this appears to be the topping. So deck, and then separation, topping. So deck, and all this appears to be topping, and or this thickness here, I'm sorry, this probably is that walkway outside. So this thickness is what I'm referencing as topping. So deck, and I'm helping you visualize topping. This is the block wall, but you see where the lines are. So deck, and then topping, and then they stuccoed right up to the edge of the deck, and then there looks like tile right there, like they tiled up to the edge of that. And then maybe stuccoed, because that even looks like it's stucco on top of the tile surface there. So, but nevertheless, this appears to be the deck thickness here. And here is that, again, that dip in the area. That dip at L. This is what I'm going to end it with, that dip that we all see. That dip we all see, this would be L, I believe. That dip with the flower pot and everything else happens also to be, post hoc, right? Happens to be right here also, with the most amount of torn out materials. Rebar pulling away. Okay. So hope porn doesn't pull up.
Post hoc.
Occurring or done after the event, especially with reference to the, okay, so assumptions that the occurrence in question. So don't get, this is what I say, post hoc. I'll say that. Be careful that we don't relate one to the other. Just because we see this and just because we see that, we start making our own story up. That's the mass hysteria part. Be careful of that. This is just data. It does deserve its own video, its own respect. There's just data though. Can we add it? We could add it. We have more data to add to it, such as reports showing cracking in its capacity, and etc. If we had more data, BMA this is my biggest major one here. The elevation changes from 1110 to 1010 would have required a BMA, which would have been stopped that puncture shear over here more than likely, because now we would have more supports. Instead of removing that, they changed it. They were removing the 1010 and making 1110, making it all one level deck. That removed the BMA. That now made our spans, made these higher. That now made our spans no longer integral. Would have been tying into that system I showed you. It no longer tying into this right here. This BMA is right here, right? This part here. This part here is more the beam that I'm referencing, and it's integral with the lower and upper floors. Removing this, put it just like this in a column format. I'm sorry, so it was on top of it because we don't see the heads of the columns. So it just did that. Now you've got this long steel trying to do all this work. The steel, and I don't know how if they changed the steel, but you've got the steel coming across trying to do the work. Wait a minute, look as the steel comes across. This is where I'm going to get in tributary areas. It comes across and it meets this wait a minute. It meets this wait a minute. It meets the column. Well, wait a minute. It doesn't meet any column. It doesn't meet the column here. It doesn't meet it here. It doesn't meet it all the way to hell out here. It's where it breaks at the pool area. So you've got this steel coming across that meets no columns. It meets no tributary, no other areas is another name for it. I would love for you guys to find it. This is my breadcrumb again. If this is the tributary area, what's the area around the punk shear protection? What is that area called? What is this area called? And once you know that, then you're like, well, wait a minute. It's got to meet that area. But if the steel is going straight, it doesn't meet it directly. It meets it laterally, sideways. In that case, you would need some what they call main bars to try to make it over there. So they would go from here to, well, wait a minute, there's no column for it to meet here. So then the main bars would have to go from here to here, some main steel, to make this steel go over to here, to support on top of this steel. It then would allow this steel to span to this steel, to transfer the load to this steel, that would transfer the load from this steel to this column and this column. You see how complicated that gets because of the way they did this? It looks, and this is my last part of it, it would look like this. Let's see if I can get you unscrewed from what I screwed you on. So, so this is the steel coming this direction, and it just goes airball, right? It's nothing. It's not landing on any columns. All right. So let's do a couple of pieces of that steel. And it's just airballing. What? Right here, airballing. What's holding it? What's holding it up? Oh, okay. Wait a minute. They got steel going the other direction. Oops. Let's get rid of the text. They got steel going the other direction. So let's use that in pink. So they got steel coming across. Pink. They got steel coming across here. But to be truthful, I have to have only two pieces of steel. So that's about all it is. Maybe it's one. You put it near the top. So this steel reaches across there into the column because it's got to transfer down there. And these other steel, they appear to go next to the column. So I've got two 60,000 psi steel here. I don't know what size is it. Number 5/8. All right, so maybe that's it. 5/8. I got two pieces of steel trying to hold this deck area together right here. The center part, as cars come down it, the deck loads all the way down this full length. This full length is loaded with weight because there's nothing there. But wait a minute, I got to add the cross steel here. Oh, wait a minute. Now look at that. I've moved this cross steel and I put two of them there because there's about two of them on each direction, right? I got to be, and to be fair about it, they're only horns. They're not fully developed. You know, they're not passing each other. So I really got to have like these little nubs. These nubs trying to make it. And maybe then, oops, nubs. Then I try to tie the steel in coming across. Frick. Then I try the steel in coming across here. That's just loading the center here now, creating this wave. Oh gosh, now look, the steel coming across here now has to take on the load. So imagine the steel here now coming across, having to take on this load of the steel coming this direction because it's not landing on a column. So now any loads here, the dead loads all start adding up. Now you got to start calculating all these dead loads, all that concrete, the pavers, not the human load. It's so insignificant at this point. I don't imagine this deck having big pool parties, 80-year-olds coming out there jamming and partying and dancing all night, slamming and bouncing on the deck. Very possible, very possible. But we just discount them. Let's just go to dead loads only. You can see the craziness that I'm trying to get the tributary area inside here is just complicated. It's really just complicated. how does it make it over to here? How does it make it to this column? How does it make it to this column? And so it would be 1, 2. How does it make it to this column, this column, this column, and this column? How does this tributary area interact? They didn't treat it separately and try to say, let's try something really fancy and modern or whatever, back then. Let's try changing colors. Let's blow blue. Let's see if we can make something fancy. Let's see if we can try something really crazy. Let's go all out. Let's go like something fancy. Pull that area so if it tries to pull down, we'll be able to pull it back, hold it like this. Something really cool. If it even would work. But let's do this. And then we still got to tie it back. That's just holding there. If you do that, all 4 posts are going to fall in. So you got to tie it all the way back to the walls and keep going back, so there's no deflection. You want no deflection here. So, because deflection is going to pull the other columns in, put a stress at the joints, and start pulling on the next slab over. So you want to make this so it doesn't deflect. Here's a column here. So then it's kind of cool. We can get to this one pretty easy, but we just got those rabbit ears, right? So the rabbit ears, they don't really do much. They work great, but we got cracks in the deck and all that. That doesn't work. So now you can start seeing, hopefully, how you need to hold this part of the deck up. It's got to make it to the column, and ultimately we want no deflection. I know some people might want to tell you that concrete flexes and all that. I have never been able to get concrete to flex without. It can take a stress before it breaks, and that's a theoretical stress. A theoretical stress that they'll tell you that's the flexural ability of concrete. Now take the rebar out of that test and just put concrete there and load it. And at the point of fracture, I'll tell you that's the point that all the stresses went through and it broke. Because I can put back every piece of broken concrete that I've ever picked up. I can put it back in plane. I don't see any deformation, any stretching happening, no rubber band, no bent metal. It's not ductile. So no matter what you do in testing and engineers, I know you guys are out there, I'm not going to hate you and trigger you on this. But you use your common sense. Don't, the world is round. Is it round? Right? So use your common sense. It's like gravity thing. You know how I feel about gravity. So I'll end it with my trigger on gravity, people. Even Newton couldn't prove gravity. He says so. A lot of people. It's equilibrium. Everything can be explained by equilibrium. So if you still believe in gravity, it's not gravity. It's equilibrium. You jump off of a damn building, your body's going to try to find equilibrium. You weigh more. You're displacing more than what's around you. I'm sorry, you're not displacing more air than what's around you, and you're going to fall through the air at what you displace, at the speed of what you're displacing, not displacing. If I put a parachute on you, now that parachute will help you displace more than what you weigh, and it will decelerate you at a certain rate. The bigger the parachute, based on your weight, the more you'll decelerate slowly because you're displacing more air as you go down. The bigger the parachute. So the more you weigh, though, the same size parachute, you're going to displace less. And so you're based on your weight, just like a boat, you're going to fall faster. So based on your weight. So that was my trigger point about I want you guys to think that, and then I want you to think and tell me, and I want you guys to break up all the concrete you want that's been set, and then show to me that when you put it back together, it's the stretch, this elongation. Don't tell me it's a theoretical elongation. Prove it to me. Put your mics on, micrometers on it. Put the concrete back in plane. Use strings, use tape lines, use chalk lines, all you want on there. Crossbars, hash bars, whatever you want. Just in concrete, no steel, no ductility in it. And break your concrete. Tell me your evaluation and your testing, because I've had a couple of you guys tell me it stretches. So give me your answer. Tell me how many percent, what's the percentage, and then show it to me in real, now that you've told me that in percentages, now show it to me in real micrometer testing. Show me that when you put those pieces back together in plane, use the micrometer, and show me where it flexed. It's brittle. It's not flexing jack. It's not flexing jack. It may compress. It may compress, and which it would crush. The materials can get with the air voids and all. They can compress and get smaller in capacity that way. Not to be confused with flexural strength law, flexural ability. They were air pockets. They were voids that you were able to compress tighter together. That's not the same. Take care. Love you all. Hope this helped. Ending the video with that one shot. Educational part. BMAs. This is what they look like. BMAs is what they look like. They're transferring the loads. And the other one would be, that looks like a straight plane now. This being number 11 here. That looks like it's dived in. Very, very interesting. We have the video showing that it looks like post hoc, that it looks like, and this image here looks like it's dipping in. We have the fireman in that column there, and this material dipping in. So it could be a local failure. I mean, look, it looks like it's missing there. It could be just a local failure, some soft concrete, and it could have punched through right there only and maybe not started anything. I don't know. It's data stacking. Love you guys. Work with it. Bye. Oh, please stick with the BMA. That's my bias. Please stick with the BMA. Don't get distracted by this. I want you to understand the BMA. The elevation changes, the BMA, the loss of that beam created that craziness that I showed you that created ultimate, that it needed to be propped up, in my opinion, and resolved, because I don't see anywhere. Well, they throw away so much evidence. They didn't really look for the steel to be able to prove, did they increase the steel sizing to handle this? Did they make like miniature steel beams inside the deck, pocketed beams inside the deck by increasing the steel across here? I would say no, that one could be debunked by just, well, if they did, they only put 2 pieces of steel outside on top of each column. So, and it's only rabbit-eared out a few inches. So even if they did, it would still just make the puncturing happen, which is a matter of fact. It already happened. All right, matter of record also. Bye.